This soft silverish metal is called gallium. Back in 1871, a Russian chemist predicted the existence of the element gallium. He hadn't found it yet, but according to his periodic system, there were some elements that were missing. He called it Ica aluminium. In 1875, a French chemist was able to obtain pure gallium through the electrolysis of a solution of gallium hydroxide in potassium hydroxide. He had found it 1 year before spectroscopically when he was looking at the spectra in zinc ore. Even though gallium might be one of the most boring and uninteresting elements in the periodic table, it is still used every day, though not for much. We mainly use it for semiconductors, LEDs, thermometers, and the solar panels on the Mars exploration rover contain gallium arsenide. It's not part of any animal or plant biology, and it cannot be found naturally in nature. The only really interesting and fun part about it is that if you give it a little time, it will melt right in the palm of your hand. It is one of 4 metals which melt at or around room temperature. These are mercury, rubidium, and cesium. Gallium is considered the least toxic, actually non-toxic, and least reactive of these elements. This is why gallistan, the compound between gallium, indium, and tin, is used in thermometers instead of mercury. If we look at the periodic table, gallium is right here. Number 31, group 13, period 4. So, as you can see, the gallium atom has 31 protons and electrons. The number of neutrons vary from ion to ion. Gallium has 3 electrons in the outermost shell and 4 shells in total. This means that the atomic ion, the gallium ion, has a positive charge of 3, just like the other elements in group 13. These elements all want to give away 3 electrons so that they get 8 electrons in the outermost shell. They want this so they can look like the noble gases in group 18. These elements are inert. They do not react with other elements. This is called the octet rule or the noble gas rule. Gallium is a very soft metal, and when it's pure and liquid, it has a very radiant silver color. When it's solid, it has a more gray color. You can actually paint liquid gallium directly onto glass and make a mirror. You can do this because, unlike mercury, gallium can actually wet a surface like glass. It has a molecular mass of 69.7, it melts at around 30 degrees, and boils around 2,400 degrees. This makes it one of the elements with the highest temperature ranges. Gallium has 2 stable isotopes, gallium-69 and gallium-71. The rest are radioactive. The 2 most important radioisotopes are gallium-67 with a half-life of about 3 days and gallium-68 with a half-life of about 67 minutes. Both are mostly used for nuclear medical imaging like gallium scans and PET scans. As I mentioned, gallium is not found pure in nature, but it works great with other metals and occurs in combination with several minerals, mainly zinc, aluminium, and coal. Of these, bauxite and zinc ore are the primary sources of gallium currently. It's not economical to mine these minerals for the sole purpose of gallium, therefore it's only a byproduct. The metal can, but doesn't have to be obtained by electrolysis of a solution of gallium-3 hydroxide in potassium hydroxide. This was how it was obtained the very first time though. This makes a gallium that is 99.99% pure. This is called the beating heart experiment.
It starts out with sulfuric acid, and we add gallium and heat it up so the gallium can melt. The sulfuric acid reacts with the gallium to form a very thin layer of gallium sulfate. This sticks to the surface and increases the surface tension of the gallium, causing it to pull itself together in a ball shape. The bubbles are hydrogen gas from the reaction.
Here you can see the increased surface tension.
Now, if you touch the gallium in the acid with an iron stick, like here, the gallium will relax and flatten out again. If you remove the iron, the gallium will pull itself together again. If you hold the iron just high enough, it will stop touching and the gallium relaxes. The gallium will go back into the ball shape and touch the iron, making a cycle that kind of looks like a beating heart. The acid is slowly dissolving the iron, releasing electrons. Normally, these electrons will go on and produce hydrogen, but if iron touches the gallium, the electrons conduct through the two metals and reduces the gallium sulfate back into gallium. The surface tension drops and the gallium relaxes and flattens out. When it's flat, the iron is no longer touching the gallium, and the acid reacts with the gallium, creating gallium sulfate, and the surface tension will increase again. Therefore, the cycle repeats. This will not last forever though. At one point or another, the solution will become too contaminated with metal salts to sustain the reaction.
So to very quickly recap, gallium reacts with the sulfuric acid and gets a thin layer of gallium sulfate. This increases the surface tension, and we have a hydrogen gas as a byproduct. When we stick the iron in the acid, it starts dissolving, creating iron sulfate, hydrogen ions, and electrons. These electrons conduct through the two metals when touching. The electrons go to the gallium and kind of kicks out the sulfuric acid, and the gallium becomes pure. Therefore, the surface tension drops again.